A rusting iron vase, a copper handle turning green, a crackling column. Real-world objects are subject to a variety of natural phenomena which lead to heterogeneous texture changes in time. The texture development of an object depends on its geometry and on its history of environmental events and conditions. In this work we present a pipeline for capturing these effects and making them available for graphical design. To structure the big variety of interesting effects and phenomena, we categorize them into three different types: chemical reactions like rusting or patination, mechanical processes like paint crackling or peeling, and finally biological growth like algae, moss or mold growing. Our pipeline can deal with all three types of effects. It is based on the idea to transfer the effects from real objects on new targets in a meaningful way. We reproduce weathering effects on test objects in our lab and capture the texture history of the object. We investigate the factors which influence the effect, and finally we provide a user interface to apply these effects in a controlled way to new objects using texture synthesis. For the data capture, we have conducted experiments to generate weathering effects on test objects in our lab. The essential advantage of the lab is that the external factors which influence the aging effect can be carefully controlled. Here, for example, rust on a statue of Mozart is caused by vinegar vapor with a well-located source. We use a scanner and camera setup to capture the shape and the changing texture of the test objects periodically. The appearance change of the captured objects depends on their geometry and on other external factors. In order to transfer the appearance effect, we have to understand and quantify this relationship. For this purpose, we describe the object's geometry and the external factors of each experiment by a set of context parameters. Here we show, for example, the ambient occlusion and the normal component in the direction of the vinegar source. We investigate the relationship between the texture history and the context parameters. With the dimensional reduction tool, we can calculate the correlations between texture and context parameters. Based on these correlations, we choose a control parameter which describes how the texture history varies over the object. This parameter will guide the texture synthesis. We provide a user interface for applying the acquired textures to new objects. The user has different options to control the final result. He can modify an effect's control parameter on the target object. Here's the original sequence. Now the user paints a different value for the ambient occlusion onto the fish tail. Our system recomputes the new result progressively in real time. Here's the new synthesis result. Our system allows the user to fine-tune the appearance history in a region of interest. Here's the original sequence. Now the user selects the fish eye and edits the appearance history diagram. Let's show some results. Patination on a copper seahorse. Rust on an iron vase. Mold on a string cheese. And finally, an example for the cascaded synthesis. paint crackling and peeling, followed by rusting.